Solving systems of linear equations by graphing. Systems, remember systems?
Yeah.
We solved systems by substitution and elimination last chapter. You have to remember how to do that. But today, you're just doing it by graphing. So you're going to have two equations graphed on the same graph. It needs to be accurate. So you need to buy graph paper, draw them as accurate as you can. I'll give you some ideas. If you don't have graph paper, I'll show you how to do it without graph paper. So kind of pay attention to how the graphing goes. All right? We've already talked about the graphing. So this is all review. You're just doing two problems together. All right? So here's the first example. I'll start with something simple. Y equals x and y equals negative x. Now to graph, you should put it in slope-intercept form, which is y equals mx plus b. What's m and b? M is slope. Yeah, we're across the y-axis. Well, look at and what you do is do this separately. What's the first equation? Where do you start? You always start at b. So what's b in the first equation?
0.
0.
Oh.
It's not listed, so it's 0. All right, so let's start with that. You have to start somewhere at a point. In this case, your point is going to always be b, and on this problem, it's at 0. Now, from the point given, you must use your slope as directions to the next point, because you need 2 points to make a straight line.
Did you say b was always going to be 0?
No, that was only yesterday for direct variation. Today, it's back to normal. Okay? So what's my slope on this first equation here? What's m? 1. The number in front of the variable is 1. So what is, and you need to look at it as a fraction. What's 1 as a fraction? 1 over 1. And we get that as rise over run. Okay? Rise, if it's positive, you go up. If it's negative, you go down. On the bottom, if it's positive, you go right. And if it's negative, you go left. Understand?
Mm-hmm.
If you have a negative, always put it at the top. That way, you're always running to the right. Any questions? All right, so let's do this one. This slope is 1 over 1 from b. In this case, b is 0. I run, or rise 1, which means I go up 1, and I run 1. So go up 1 and to the right 1. And that's your next point. Now, if you don't have graph paper, and even if you do have graph paper, this is very smart to do this. Continue going. Rise 1, run 1. Rise 1, whoops, run 1. And just you keep going. That way you know you're making an accurate graph. If you're doing it freehand like I am, you want to do this. And not only that, but go backwards. If I rise 1 and run 1, positive and positive, let's go backwards. Let's fall 1 and go to the left 1. If I go down 1 and left 1, I'm on the line. If I go down 1 and left 1, I'm still on the line. Okay, so you can go backwards by changing both the signs. You need to be able to do that fluently, easily, especially if you're not using graph paper. Right? We were never given graph paper. So you have to do this. You have to be good at graphing. Now, look at this one. What's B? Oh, we already know our answer. The answer is where the two lines cross.
Where do they cross?
No, cross at 0.
Oh.
0, 0, it would be the answer. Now, since we have B, what's your slope? What's your question?
So the y equals x. So
is 0 and m is 1.
So that's the answer.
Not yet. I'll tell you here in a second. So let's graph this problem now. You got to graph both of them on the same line, same graph. B is 0 here. What's m? So m is -1. What is -1 as a fraction? -1 over +1. So now from 0, we're going to fall 1 and run to the right one. Down 1 and to the right one. Down 1 to the right one.
But now those lines don't do the same thing.
What do you mean?
Oh, I get it. Never
Where do
mind.
they cross?
At
Not at 0. At 0, 0.
So
Oh,
that's our
right.
actual answer is going to be 0, 0.
This is the answer.
So
You have to have the graph. I don't care if you know where they cross. You have to have the graph and the answer.
So that's all you're finding is where they cross.
Yep. But what if they don't ever cross?
Then
What if they're
it-
parallel?
right parallel.
Parallel?
No, then you write no solution. They don't ever cross. No solution.
Parallel.
Here's what you're finding. What value of x and y will work in both equations? That's what you're finding. In this case, when x is 0 and when y is 0, that'll work in both equations. If they're parallel, there won't be any answers where they work in both equations, right? What if you have a line on top of another line? How many times do they cross? Infinitely many. Infinitely many. I'll do, well, I'm not going to do one. Infinitely many, meaning they're on top of each other. Let's say that's the line, and then you draw another line that happens to be right on top of it. Well, every point on that line, on both lines, will work in the system. All right, so let's do example 2. This is a little different. Y equals -x minus 4. Graph that one first before I give you the next one. Everybody try graphing now.
Wait, so that's the positive form,
Negative 4. So where are you starting? You always start at B. Start at C. The formula is y equals mx plus b, so since that's minus 4, you're going to start at negative 4. Over here, I guess. Alright. What's my slope? -1 over +1. So I go down 1 and I run 1.
Wait.
How'd you get that?
Never mind, I got it.
Whoa.
The slope?
Yeah.
What's the number in front of x? 1. So what's that as a fraction? That's right. Rise a -1, that means you go down 1. And you run a +1, that means you go to the right.
Oh.
Okay? Alright, now wait. Now watch what I do. I'm gonna go backwards. Instead of going down 1, I'll go up 1. Instead of going to the right 1, I'll go left 1. And I'm just gonna keep doing it. Now, here's the next equation. X plus y equals 0. What's wrong with that?
It's not in the equation.
That's right. Y is not by itself. So you got to get y by itself before you start. Huh? No. Get x by itself. Or y by itself. Hey, you got to subtract x from both sides. So now you have y equals -x.
But
Where
we
do you
don't have B.
Right. So where do you start? Start at B. What's B?
0.
They're not going to write +0 in the book. So they start here. What's your slope?
-1 over 1.
-1 over +1. go down 1 and over 1. Down 1 and over 1.
But the lines don't cross.
That's right, because your slopes are the
Still
same. They're the same. The slopes are the same, but your B's are different. Infinitely many, your slopes are going to still be the same because they are parallel. One line on top of another is parallel, but your intercepts are going to be the same. Here, the intercepts are different. That's how you know whether it's a no solution or infinitely many. Okay.
So what's the same if you have a determinant? Well, I know that.
Well, the slopes will be the same, right? They have to be the same. But your intercepts will be the same as well. If they're on top of each other, they're going to cross at the same point. So the B's will be the same as well. All right. So here's what a problem would really look like. Example 3. 3y minus 7 equals 2x. Everybody graph that first. That means you got to get the y by itself. Don't freak out. Just get y by itself first. Do not use your calculators. You cannot graph if you're using your calculators. I love that, man. It was only reading. Come on, get y by itself. Remember, chapter 1, section 6, circle the term you're solving for. Step 2, move all other terms across the equal sign by adding or subtracting.
But what do you add or subtract?
Step 3, separates the coefficient from the variable by multiplying or dividing. But when you multiply or divide, rule 2 says you must multiply or divide every term. So, slope-intercept form here is y equals 2/3 x plus 7/3.
That's how I feel.
I can't graph a
I'm
fraction.
What about people watching?
If you want to,
Yeah. Like, changes times the by 3.
But then you're back up to here.
Oh,
All right, so here, pay attention. Because you can do this freehand and still find the answer if you just stop talking and listen. You probably get a lot of your questions answered. What?
Can't you just put the 7 marks in that number?
Can I use an eraser?
Yes, that's a great idea. What is it?
2.
All right, so it crosses where we start.
2. 0.
Everybody say it.
Start at B.
What's B?
0.
2.
It's 2.
1.
That's
Two.
2 and
Okay,
1/3.
strike 2.
2 and 1/3.
Wow, 2 and 1/3,
Oh,
people.
I just started that.
Because that's D.
Here, why I was trying.
But it's a start at B.
Wait a minute. Wait a minute. Just sit there.
Mr.
Yes.
Okay, so you turned it 2 2/3 into that.
So 7/3 into a mixed number, just so I would know exactly where to put my point. 2 and 1/3 is right here.
That's not cute.
What?
Well, welcome to math. Now, what's my slope?
1/3.
Oh my gosh. Look at your nose. Look at what you have.
Oh.
2/3. So we're going to rise 2. Now watch, everybody. I'm just going to draw my hash marks before I get started. I'm going to rise 2. That means I don't go up to this next hash mark. I go above it because that's one whole unit from 2 and 1/3. So I go up 1, 2, and I run 3. I'm still above that hash mark, but to the right. Got 2 and 1/3? Right here? I said that's 2 and 1/3. That's B. You start at B. You You just repeated it to me a minute ago. Start at B. And you rise 2 and run 3. Make sure, if you're in between hash marks, that you stay in between the hash marks.
Shot.
Hash brown words.
Okay, got it?
So it's
Well, we haven't done the other equation. Here's your other equation. Y equals, or y plus 2x equals 5. Y plus 2x equals 5. Put it in slope-intercept form and graph it accurately.
Okay.
slope intercept.
Slope intercept.
Slow down.
Forgot.
That's slow enough. What's your question? Yes.
I don't like this.
Get y by itself by moving all other terms across the equal sign by adding or subtracting. Do not tell me that y equals 3x.
Hey, wait, I just divided by 2.
Why? You're not separating the 2 from the x. You're getting y by itself. Chapter 1, section 6. Learn your notes. That I told you to memorize for the rest of the year.
Well, you just told me to divide, so I divided.
No, I did not.
Yeah.
You said to get y by itself.
Step 1, circle the term you're solving for. Step 2, move all other terms across the equal sign by adding or subtracting. Step 3, separate the coefficient from y if it's not 1 by multiplying or dividing. Well, it's already 1. So what do we have here? This doesn't have an x with it. You can't put these two together, people. Stop doing that.
Oh.
Negative 2x plus 5. You always put your variable term first. What's b?
B is 5.
5. We start where?
At 5.
1, 2, 3, 4, 5. Watch. What is my slope?
2. Negative 2.
Negative 2 over positive 1. I'm going to rise negative 2. That means I go down 2. 1, 2. And I'm going to run a positive 1.
Oh my
You see it? From 5. We start at 5. That's our B. Okay?
Yeah.
We start at 5. We go down 2. And we run 1. And look at that. You found, without an accurate graph, where they cross. What's that coordinate?
3, 1. Done.
You always give x first. Come on, people. This is graphing.
1,
It's
3.
your 3rd year doing this. So this is your solution, and you have to have a graph. You need to be very accurate with your graph.
Well, I'll be in here tomorrow.
All right. Any questions so far?
Very.
It's hard because we've not studied and done what we should have done all along.
Okay, swimmers here.
What does that have to do with math?
Exactly.
I'm still just like, yes, buddy.
Assignment. 1 to 17 all. 24 and 25.
Oh, yeah, wait.
I want to leave.
What did I do?